Okay, so let's look at this graph here. It says it has its first turning point in the interval from pi to 2 pi and multiple turning points because of the sine function. Okay, it's just going to go up and down. And the interval is going to be pi because of the periodic nature of sine x and its zeros. So we want to show the horizontal asymptote zeros and the f prime. Okay, so first of all, let's find our horizontal asymptote here. Okay, so limit as x goes to infinity of f of x. Okay, the sine x is going to be stuck between -1 and 1, where the ln x, although it grows very slowly, it eventually will go to infinity. So we know that we have a horizontal asymptote at 0. Okay, so what about the zeros? Well, the zeros are going to be where the sine x is equal to 0, where the numerator is equal to 0. So x is equal to 0 at 0, pi, 2 pi, dot, 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 dot. Okay, so this will be our 0 points. And we want to now find the turning point. So let's find the derivative. Okay, so actually we really should work out the domain here too. Let's do the derivative first and then we'll work out the domain. Okay, so part 3, let's find out the derivative. Okay, so f prime of x is going to be equal to cos x log x minus sine x times 1 over x. Okay, so that's going to be our derivative function. So we get log x squared in the denominator. Okay, we want to find out where this is equal to 0. Now this is not something we can find equal to 0 because of the nature of the equation. Okay, so we're not being asked to find the zeros of this derivative, we're just being asked to show the derivative. Okay, so what's the domain of this function though? Okay, so sine x has a domain of all real numbers, log x has a restricted domain, and log x can equal 0 in the denominator. So the domain of this function is going to be, well, the log x must be greater than 0. Okay, but the denominator cannot be equal to 0, and when log 1, when x is 1, log is 0. So x cannot be equal to 1 either. And since it's 0 in the denominator, we really are going to have a domain restriction of dividing by 0. So we're going to have a vertical asymptote going on here. Okay, so let's start graphing this. We have a 0 at 0. Okay, we have another 0 at pi. Pi, let's say, is right about here. Okay, and we have 2 pi, is over here. And this asymptote, it actually is going to go through the asymptote multiple times, but it's just going to get closer and closer. The bumps are going to get smaller and smaller as we do this. So what's happening here at the asymptote? Well, I want to know what's going on. Is this going up or is this going down? Well, we can kind of test this using slopes, I suppose. So we can plug in, 0.5 into here and work out a slope. We could also just do a limit here of the sine function. So I'm just going to do a limit. So limit as x goes to 1 from the negative side of f of x. So what's going to happen is we're going to be going to 1. The numerator is going to be in quadrant 1, so it's positive. The denominator is going to 1 from the negative side. And if you think about what the log function looks like, okay, it looks like this. And 1 from the negative side is negative. So that's going to be negative infinity. Okay, so what's going to happen here is it's going to dive down to 0, or to negative infinity. And then if I want to do the limit from the other side, as x goes to 1 from the positive side, same thing, except now it's coming, the sign is still positive. Now we're approaching 1 from the positive side, so that means the log is positive from that side. So we're going to divide by, it's going to be 1 divided by positive 0, which is going to be positive infinity. Okay, so it's going to go up like this. Going to go through that point there. it's going to have its first turning point in here, and it's just going to have repeated turning. It's going to go up and down, up and down, up and down. Okay, and the bumps are just going to get smaller and smaller and smaller, and it's going to tend towards that asymptote. Although it crosses that asymptote, it's going to get closer and closer to that asymptote for each step. Okay, so I think this is all that this question's asked for. So this is what my graph's going to look like. Okay, I've got my domain restriction. I have my vertical asymptote. I figured out how it's going through the asymptotes. And I have my zeros, and I can see that there's a horizontal asymptote because it's just going to get narrower and narrower and narrower as we move along the x-axis.